The next tool that we want to introduce, getting us closer to our goal of being able to find all complex zeros for a polynomial function, is the rational zeros theorem. This theorem tells us that for a polynomial function, where each coefficient is an integer, if there is some number p over q, so some rational number, if that number is a rational zero of f, meaning evaluating that function at x equals p over q, then that value p must be a factor of a sub 0, that constant that makes up the last term of our polynomial, and q must be a factor of a sub n, the leading coefficient, or the coefficient of that leading term of our polynomial. So we're going to use this rational zeros theorem to generate a list of potential zeros for some given polynomial function f of x. What's important to keep in mind is that idea of potential zeros. We're going to generate lists of numbers, some of which, one or more of which, may be zeros for that function. In example 8, we'll start this process by first coming up with a list of all of our values for p. When we consider the values for p, we want to look at that constant term, so we need a list of all possible factors of positive 9. That would include 9, 1, and 3. But we could also multiply two negative numbers together to get that positive 9. So for each of these values, we're going to consider both the positive and negative versions of each. For q, we're going to look at the coefficient of our leading term, which in this case is negative 3. Our factors in this case would be 3 and 1. But we need to multiply together a negative and a positive number. So what we're going to do is, again, consider both positive and negative 3 and positive and negative 1. From here, what we're going to do is generate our list of all values p over q by combining every pair that we can possibly match together from our list of p and q. So to start off, we can consider plus or minus 9 over positive 3. We can consider plus or minus 9 over 1. Then we can pair plus or minus 1 with 3. And with 1. And then for our last two pairs, we'll be looking at plus or minus 3 over 3. And then plus or minus 3 over 1. So in each case, we have both the positive and negative versions of each of those pairs represented. Now what we want to do is filter through that list and simplify where possible. For instance, 9 over 3 is going to reduce to 3 over 1. So our actual list of values for p over q will include plus or minus 3, plus or minus 9, plus or minus 1/3, plus or minus 1. When we look at plus or minus 3 over 3, this will reduce to 1 over 1, which is just 1. We already have that number taken into account. And we have 3 over 1, which we already have taken into account. So this list of values for p over q, this list of rational numbers, are all values that are potential zeros for that given function. What we would need to do then, and what we'll get to soon, is plugging all of those values in until we identify one of those as a zero for the given function.